Okay, so now you're going to be asked to draw chair conformations of cyclohexane. And the reason you're going to be asked to do this is because it gives you great power if you can take three-dimensional objects and get your pencil used to putting them onto a two-dimensional piece of paper. All right, so this is it's going to end up opening your eyes to space and shapes. All right, and so that's why we have to do it. So the first thing that you're going to do when you're drawing these steps, of course, come from Klein, and I think they're fantastic. So the first thing you're going to do when drawing a chair conformation of cyclohexane is you're going to draw a wide V, okay? So you draw a wide V, and that's, of course, a carbon and another carbon, all right? Then step two is you draw a 60-degree angle. You draw a bond going down, all right? Then after that, you draw one going up. Now watch, this one going up has got to be parallel to that one. So, okay? You see that? See how those are parallel? Okay? And then you draw another one going down that's parallel to that. Okay? You see that? Okay? And then finally, you put the two together. Okay? So that's these 5 steps right here. Again, we draw a wide V. Goes 60 degrees down, then we draw one parallel to that, boom, then we draw one parallel to that, boom, and then we just connect them, okay? So that is a chair conformation of cyclohexane. Now what we want to do is we want to put things on it, okay? I think I pointed out to you a second ago that there are parallels, 3 sets of parallels, right? Because there's 6 bonds. So those 2 parallel, those 2 are parallel, and these 2 are also parallel. Now each carbon has 2 substituents. There's when it's just cyclohexane, those are hydrogens, right? So the ones that are pointing up are called axial because they're in the axis of the cyclohexane. The ones that are going Y, that are called Y here, are called equatorial, and that's because when we build them all, you'll see they're sort of like going around the equator of the molecule. Okay, so let's draw those now. After we've drawn those the cyclohexane. Then you draw all of the, where's my marker here? I'm going to draw them in red. Then you draw all of the axials. So axials just go straight up and down. So it's every other one, right? Can you see those carbons are pointing up? This carbon's pointing down with respect to the ring, right? So that'll go down. This carbon's pointing down. Can you see it's going down? Okay, and that carbon's going down, okay? So, and that's what I've got over here, all right? It's a little neater if it's smaller. Now, when we draw the equatorial groups, they go out, but they're also still parallel to these other lines. So watch this. Let me go with blue or gray. Can you see I've got my gray line right here? So my equatorial is going to be parallel with that, right? And this gray line here, my parallel is going to be equatorial with that. Wait, that's not right. No, it's this. No, it's not right. It's this gray line. Because it's every other one, right? So it's that gray line is going to be parallel with that, okay? And so this one's got an equatorial, so that's going to have to be parallel with that, right? So it's every other one. So that's going to be like that. Like, see, boom, boom, boom. And then this one's going to have to go down because it's every other one, right? So I think I'm missing some. Oh, this one here, it's every other bond. So bond, bond, boom, and it's going to be parallel with that one, right? Can you see that? Those 2 are parallel. And then finally, these 2 are also parallel. Okay? So that's how we draw the equatorial. Equatorials in gray here, and the axials are in red. And so in future conversations, we'll talk about the energetics of those, what happens if we put a methyl group or a bromine atom on one of those. But for now, I encourage you to when this video is over, to draw a couple cyclohexane molecules, and perhaps you should even watch the video again. This is going to be really painful if you can't get it, and if you can get it, it's going to be great. Good luck.